Welcome to this presentation of the CITI-SENSE app development for crowd sensing of environmental data and air quality. My name is Arne Berre from SINTEF in Oslo, Norway, and I'm doing this presentation on behalf of also other partners that has been involved in the app development in CITI-SENSE, as you see on the list here on the first slide. The CITI-SENSE project is one of 5 sister projects dealing with development of CITI-SENSE observatories for various areas. CITI-SENSE is focusing on air quality, but other projects are focusing on water quality, biodiversity, and other areas. I will at the end of the talk about how we plan our pilots now in 9 different cities in Europe in the coming months. The CITI-SENSE project is currently halfway in a 4-year project and has 28 partner organizations, including also partners from South Korea and Australia. You see the web reference for the project web portal here, as well as also a web reference for a common portal for all of the CITI-SENSE Observatory projects. Here is the logos of the 28 different partners in CITI-SENSE, ranging from sensor developers to sensor platform providers, to infrastructure providers of data management infrastructure and visualization and app development, and further to deployment in cities and support for the citizens' empowerment and social engagement. Those that are familiar with the GEOS common infrastructure might recognize this picture. Here we have emphasized in red where we will focus now in this talk on the CITI-SENSE Observatories part for mobile apps, also doing other things related to portals, but in particular the mobile apps and their connections to sensors, and particular smartphone connected mobile sensors with Bluetooth, also similarly supporting in situ sensors and more static sensors, and how the data flow is going from the sensors to the mobile apps and further to storage in a WFS server, and with potentially associated linked data server, and further being available in the GEOS infrastructure. The main idea is to take advantage of the increased opportunity of cheaper mobile sensors that can enlarge the number of sensors being available in the community. And in particular in this presentation we'll focus on the app development taking advantage of this. So one of the sensor sets we are doing is related to citizens' observations of their current environment, dealing with noise, UV, photo of the current context, and ability to provide answers on questionnaire from a human sensing point of view, different kind of weather information. And I'll show you a little video of our presentation. Here we see the UV sensor attached to outdoor clothing, and also the weather meter measuring wind speed and humidity and other temperature related measurements connected to a smartphone. Next we have the personal sensor package that has been developed in the CITI-SENSE project, in particularly aimed at air quality sensors such as NO2, O3 and CO. In addition to such things as temperature and humidity. This can be worn on the body, biking or walking, and I'll also show a little presentation of this. Here we see the sensor package attached while walking as well as when biking, and the associated data is then being collected into the smartphone and further uploaded to the common shared server, as we will see later in the architectural presentations also. Next we're going to show some of the screenshots and the usage of the app. We start here with the ability to start up for measurements. We can look at the last measurements. We can create new observations, view current observations, analyze the results and the current evolution of this. We give an example of using of the acoustic sensor for doing sound or noise measurements, and we can see the collected results here on this diagram that shows over time how the zone measurement is varying, and we can do the similar thing also for other of the sensors. After having done a measurement, we can stop and analyze the result and provide further comment. So for instance, for the noise, we can comment if the noise has been pleasant or unpleasant and what the source of the noise has been. Further, if it's well, both pleasant and unpleasant, we can take pictures of the noise situation. Here we just took a picture of the weather meter sensor, but it will be typically the context of where the sound has been measured, and this can be further reported and associated also with the geospatial location of where this recording has been taken place. It can be analyzed according to a scale of an acoustic comfort index, so we can see relative to the scale from excellent to unfriendly how the sound measure up with comparable results. And we can do the same also for the thermal index on the temperature, combining factors such as the heat, the wind, and the humidity to look at thermal comfort index in a similar way. The activity level of the persons involved can also be collected, and we can look at the measurements here to what extent there has been kind of low or high physical activity involved in the situation during the measurements. It's also possible to look at the measurements on the map and to have different color codings based on the kind of measurements we want to analyze, and also compare this with the reference data in the area and provide further recommendations related to the situation around this. The air quality sensors are continually connected from start, and we can also look at the information from the personal sensor package of the air quality information that is being collected. If we take a look now at the architecture, we will see that the smartphone is using both localized sensors such as the acoustic sensors and other sensors, and is also collecting through Bluetooth connected sensors as we have for the weather tracker or the personal sensor pack. And this is stored on the smartphone for further communication through the common services, where we're using an ODC standard and also based WFS transaction server for the dataset collection. And this is further being reported as datasets into the GEOS common infrastructure once we have datasets of, say, sufficient quality to make that shareable. From the larger point of view, we can see that the architecture support a number of input sensors, both human and physical, mobile, and static sensors through the whole life cycle, from the observations to the handling of the data. It has an opportunity for a number of front-end platforms, not only mobile but also static platforms of various kinds that can all feed into the common shared sensor storage and observation storage based on the WFS standard, and also support for sensor observation service with a number of potential output formats, and including also an option for linked data. This is being made available at a suitable point in time to the Common Service Registry and being available to the GEOS common infrastructure. The way it is planned now is basically to try out the provided solutions in practice in 9 different European cities. And we see only a part of it here with the mobile app support, but we also have web portal support and other sensor packages for urban quality, measurement in public spaces, and also doing school indoor quality with various indoor related parameters. This is all taking place in the context of the architectural platform, from the sensors to the communication and information management, and has also aspects on how to handle participation and empowerment of the involved citizens and the involved stakeholders. So this will take place now with incremental improvements for the next 2 years, and you will find further information on this on the Common Citizens Observatories portal together with the other Citizens Observatory projects, as well as through some of our social media accounts, and finally also on the Citizens website itself. So thank you for your attention.